Question 1. So what fraction of the shape is shaded? Well, I've done it in columns. So 1, 2, 3, 4, 5, 6 columns out of the 8 columns. But we need to simplify the fraction, so halve the top and bottom, you get 3/4. If you counted squares, that would have been fine, but you'd have to carry on simplifying it down until you got to 3/4. Now for part B, we're asked what fraction of the triangle is not shaded. Well, the whole is 1, so it's going to be a whole take away 3/10. Well, a whole is really 10/10, so 10/10 take away 3/10 is 7/10. So it's the rest to make you up to a whole. Write 0.047 as a fraction. Well, this is the tenths column, the hundreds column, the thousandths column, so that's 47 over 1,000. What I suggest you do when you think you've got your answer, pop that back into your calculator and press the SD button and just check you get what you started with. Write 3 1/4 as a decimal number. Well, again, I would rely on your calculator if you can't just do this by sight. Using the mixed fractions button, put 3 1/4 in, and then press the equals, and it will give you, or the SD button, I forget which, and it will give you 3.25. Question 2, how many televisions were sold on Monday? Well, each of these rectangles is 8 televisions. So for Monday we got 3 lots of 8, which is 24. Part B, how many more were sold on Friday than were sold on Tuesday? So let's look at Friday and Tuesday. Well, Friday's got an 8, an 8, and an 8, and then half a rectangle, which is 4. So that's 28 in total. Tuesday's got an 8 and an 8 and a quarter of a rectangle, which is a 2. So that's 8, 8 and 2, which is 18. So how many more were sold on Friday? Well, 28 take away 18 is 10. On part C, we've been told that the prices of televisions were reduced by 1/3. There were 549 before the reduction. So I would start off by working out the reduction. So what is 1/3 of 549? So pop into your calculator 549 times 1/3. Or you could have done 549 divided by 3, and that gives you £183. Now that's the reduction, that's how much is being taken off the price of the TV. So what is the sell price of the TV? So you take your 549, the starting price, take away the reduction, 183, and that gives you the sell price for the TV of £366. Question 3. Part A, find the area of the shape. Well, that's the space inside the shape, so the number of squares inside the shape. I've put a blue dot inside each of the squares. There are 18 squares inside the shape. Now for part B, that's the perimeter of the shape. That's the length when you run all the way around the shape. So I've put a little pink dot next to every single unit length. So if you add up all those pink dots, you get 22. Just be ever so careful when you go around the corners. People quite often forget that that's 2 lengths there. Alright, you're going across there and then down there. So that's 2 units there. Same over there. People often forget to include 2 over there. Part C, how many lines of symmetry does the shape have? Well, it's only straight down the middle. That's the only place you could fold it, and it would fold onto itself. And part D, in this space below, sketch a hexagon. Well, as long as you've got a 6-sided shape, then you're fine. A hexagon has got 6 sides. Question 4. So the spinner has got 4 yellows, 3 greens and 1 black. We spin the spinner once, circle the word from the list below that best describes the likelihood it lands on black. Well, the chances it lands on a black is 1 out of 8. So it can happen, but it's fairly unlikely. So unlikely is our answer there. Part 2, on the probability scale, mark with a cross the probability the spinner lands on a white. Well, it can't land on a white. There aren't any whites. So that's impossible. So that's a probability of 0. And then for part B, the probability it lands on a yellow. Well, yellows is 4 out of 8. So that's exactly a half. It's evens. It's 50-50 that you'd land on a yellow. So that's why we've got to put an X on the half. Question 5. Measure the length of AC. Well, just using your ruler, of course, you will get 5.5 centimeters. Write down the mathematical name for the line AB. Well, like that, a line that goes from the outside of the circle through the center to the other outside of the circle is called the diameter of the circle. Now, the line AC, any line from one part of the circle to another part of the circle that doesn't go through the center is called a chord. And the shaded region between a chord and the circle is called a segment. Question 6. Write down the mode. Well, the mode is the number which crops up most often. The only number that crops up more than once is 4, which crops up twice. For part B, find the range. Well, the range of a set of numbers is the biggest number, take away the smallest number. So that's going to be 16, take away 3, which is 13. And part C, work out the mean. Well, to work out the mean, you add all the numbers up. So you add up all of these numbers here and you get 56. And you divide that by the number of numbers. Well, there are 7 numbers there. So you do 56 divided by 7, giving you a mean of 8. Question 7. So for part A, a piece of meat weighs at 1,500 grams. Work out how long it takes to cook. So let's first of all look at the variable bit, the bit that's not fixed. So we're told that every 500 grams you have require 40 minutes of cooking. So write that down as the sort of your opening statement to help you work out the proportions. Now, our piece of meat weighs 1,500 grams. Well, that's 3 times as much meat. If you can't just see that, just do 1,500 divided by 500 on your calculator, and you will see that that's 3 times as big. So 3 times as big a piece of meat is going to take 3 times as long to cook. 3 lots of 40 minutes is 120 minutes. So that's the variable part, but we're also told that as well as that, we've also got to add on an extra 15 minutes. So 120 minutes plus the 15 minutes, 135 minutes. Now for part B, it takes 3¼ hours to cook a different piece of meat. How much does it weigh? So we've really got to do the same thing but backwards. So 3¼ hours is 180 minutes being the 3 hours, plus 15 minutes being the quarter. That's 195 minutes in total for cooking. Now let's start off by taking off that extra 15 minutes it needs. That leaves us with 180 minutes worth of the variable component, 180 minutes. Now back to our starting point. We know that 500 grams takes 40 minutes to cook. And we've got 180 minutes worth of cooking time remaining. So 180 is 4½ times 40. I've worked that out by doing 180 divided by 40. So this is this relationship here is 4½ times bigger than this. So how many grams worth of meat am I going to be cooking? It's going to be 4½ lots of 500. 4.5 times 500 is 2250 grams. Now for part C, we want to take the chicken out at 1:30 in the afternoon, 13:30, after an hour and 50 minutes worth of cooking. Now I'm just going to work my way backwards bit by bit. So first of all, I'm taking off an hour. So 13:30 take away an hour takes me back to 12:30. And now I need to go back at another 50 minutes. Well, that's going back another hour, less 10 minutes. So that takes me back to 11:40. Question 8. So the cost of 2 adults and 3 children is 475. I've got to work out the cost of 1 child. So 475 has bought 2 adults and 3 children tickets. So let's first of all take away the 2 adult tickets. They were 110 each. So if I take away 2 lots of 110 from 475, that leaves me with 255 Hong Kong dollars. That's how much the children's tickets cost. Well, I brought 3 children's tickets, so 255 divided by 3 means 1 child ticket must be 85 Hong Kong dollars. Question 9. Find two common factors of 12 and 18. Well, the common factors of 12 and 18 are 1, 2, 3 and 6. So you've got to choose any two of those. Now find one common multiple of 12 and 18. So just do the 12 times table, the 18 times table. Any numbers which appear on both lists are common multiples. I've stopped after I've got to the first one, the lowest common multiple, which is 36. So that's an example of one of the possible answers, of endless possible answers, is 36. Question 10. So the angles of a quadrilateral, a four-sided shape, add up to 360 degrees. Remember, it's two triangles effectively. If you cut it down there, each triangle will be 180. So a four-sided shape, the angles add up to 360 degrees. So this plus this plus this plus this must equal 360 degrees. So 48 plus 2x plus 67 plus 3x equals 360. So I've constructed an equation. So I'm going to start off by simplifying it. So gathering up my x's, 2x plus 3x is 5x, and 48 plus 67 is 115. Now I'm going to solve this equation now. So I'm going to start off by taking away 115 from both sides. So 5x equals 245. Now I'm going to divide both sides by 5. So x equals 245 divided by 5, which is 49 degrees. Question 11. So we've got to work out the volume of this prism. Well, how do you work out a volume of a prism? Step 1, you work out the area of the cross section, so the area of the end bit, and then secondly you multiply this by how deep the prism is. Now the area of the end bit on this occasion is a triangle. How do you work out the area of a triangle? It's half times base times height. So half times 12 times 9. Or half times 9 times 12. So that's that component. I then multiply this area by the depth of the prism, so I multiply that by 25, and that gives me 1350. Question 12. So part A, we work out the value of P when D is 7 and E is 9. So start off just by substituting straight in. So P equals 3 lots of D. So that's 3 lots of 7, so 3 times 7, and we're taking away 2 lots of E, so that's 2 lots of 9. Now if you put the brackets in like this, you could simply just substitute that straight into your calculator, press equals, and it will give you the final answer of 3. Equally, you could just work out each component in turn. 3 7s are 21, then we're taking away 2 9s are 18, 21 take away 18 is 3. Now for part B, to simplify this, gather up the x's. So we've got 6x gathered up with plus 3x, so that's plus 9x. And then we're gathering up the y's. Minus 7y plus 5y is minus 2y. Now part C, to solve this, how do we undo an adding of 5? We take away 5 from both sides, so 4t equals 13. How do we undo this timesing by 4? We divide by 4, so t equals 13 to be divided by 4, 13 over 4. Now that's perfectly acceptable as a final answer, but if you wish you can give the answer as 3 1/4 or 3.25. Now part D, factorising. This means putting the brackets in. So we put a bracket in, and on the outside of the bracket we put the highest common factor. What's the highest number which goes into 25 and 30? Well, that's 5. So we take 5 outside the brackets. Then we say to ourselves, 5 times what gives us 25m? Well, that's 5m. Get the sign right, it's a plus. And then we say to ourselves, looking at the second clause, 5 times what gives us 30n? Well, that's 6n. Now these are always easy to check. Just work backwards, just expand this and check you get back to your starting point. 5 lots of 5m is 25m plus 5 lots of 6n is 30n. Now part E, expanding this is when we get rid of the brackets by using the clause method. So we start off with this first clause, P times 2P. So P times 2 times P, or if you like, 2 times P times P. P times P is P squared, and it's 2 lots of that. So that's 2P squared. Then we're taking away P times 3, or 3 times P, which is 3P. Question 13. So for part A, we've got to write down the ratio of the weight of butter to the weight of flour. So the butter is 125 grams, the flour is 175 grams. So that's the ratio, but we just have to simplify this. So they both end in a 5, so I would start off by dividing both by 5. That gives us 25 to 35. They still both have 5 on the end, so they can still be divided by 5. So dividing both by 5 again, we end up with a final ratio of 5 to 7. Now for part B, Alison wants to make some of these cakes to sell at a fair. She only has 750 grams of butter and 8 lemons. So let's start off with the butter. So she's got 750 grams. Each cake requires 125 grams of butter. So if we do 750 divided by 125, we can see that we can make 6 cakes with regard to the butter. Now moving on to the lemons, each cake requires 1.5 lemons. So we've got 8 lemons, so 8 divided by 1.5 means you could actually make 5 1/3 cakes with regard to the lemons. Well, obviously we've got to be making whole cakes, so lemons is our greatest constraint. That's the thing we're going to run out of first, so we can only make 5 full cakes. So the answer is 5. Question 14. So it may well be that a lot of these you can put in order just by sight. For example, 3/4 is clearly greater than a half. But I just want to give you a strategy that really just takes any thought out of it really. So if I were you, I would just get out your calculator and convert each of these fractions into decimals. So simply using the fractions button, just put 5/12 equals, with the SD button you can just turn that into fractions. So if you turn them all into fractions, then it's very easy to work, see which is smallest, and you work your way up. So this is the smallest, then this one, number 3, number 4, number 5. Then of course just make sure your final answer you revert back to the fractions. You don't go and write down the decimals. Those are just there to help you work it out. Now for part B, in order to divide fractions, what you do, the first fraction stays the same. You change the sign from division to multiplication, but the second fraction only flips over. So it's no longer 4/5, it's now 5/4. Now once you've turned it into a multiplication question, it's one of the easy ones where you just do top times top and bottom times bottom. So 2 5s are 10, 7 4s are 28, that's 10/28. That's our answer, but just to simplify that, we can halve top and bottom, giving us the required 5/14. Now for part C, in order to subtract, we're going to need to have a common denominator, but before you do any operation when you've got mixed numbers, I think it's best to change your numbers into a top-heavy fraction. So just focusing on the left-hand side, 3 1/6 is 19/6. 3 6s are 18, add the 1, 19. And 1 2/3 is 5/3. 1 3 is 3, add the 2 is 5. Now in order to get a common denominator, we can have a common denominator of 6. So the first fraction stays the same. The second fraction we need to multiply top and bottom by 2, giving us 10/6. Now that we've got the common denominator, we can just subtract the numerators. 19 take away 10 is 9. So we've got 9/6, which is 1 3/6, which is 1.5, which is what we've got on the right hand side. Question 15. So Mike buys C pens and R rulers. We've got to write a formula. So think about it. With the pens, if we bought 10 pens, that would cost 10 lots of 24. If we bought 5 pens, it's going to cost 5 lots of 24. Well, we're just buying C pens, so it's going to be C lots of 24, which is 24C. Similarly with rulers, Okay, each of them cost 37 cents. So if we bought 2 rulers, we do 2 lots of 37, 5 rulers, 5 lots of 37. Well, we're buying R lots of rulers, so that's R lots of 37, which is 37R. So we're spending 24C on pens, 37R on rulers. So the total amount that Mike's spending on buying pens and rulers equals 24C plus 37R. Question 16. So I think this is another one best thought of just by way of proportion again. So focusing on the average speed. The bus is travelling at 50 kilometres per hour. So every hour we travel 50 kilometres. Or turning that into minutes, every 60 minutes we travel 50 kilometres. We do 50 kilometres in 60 minutes. Now I need to go and work out how long it's going to take me to get to do 165 kilometres. So I need a way of, via proportion, moving from 50 to 165. Now there's many ways to do it. You could divide by 50, then multiply by 165. But what I've chosen to do, I've just started off just by dividing by 10. So if 50 kilometres takes 60 minutes, 5 kilometres takes 6 minutes. Now I'm aiming to do 165 kilometres. So how do I convert 5 into 165? What proportion is that? Well, with my calculator, 165 divided by 5 is 13. So this is 13 times as many kilometres. So it's going to take me 13 times as many, 33, excuse me, that's 33. 33 times as many kilometres, so it's going to take me 33 times as many minutes. So 6 times 33 is 198 minutes. So 165 kilometres would take 198 minutes. Now I've got to give my answer in terms of hours and minutes, 60 minutes in an hour, so I can get 3 hours out of this using up 180 minutes, so 18 minutes left over. So 3 hours, 18 minutes. Question 17. So we've got two things going on here. First thing we know is that with regard to this tree D, it's 110 meters from B. So we need to draw with our compass an arc representing all the points which are 110 meters from B. Now we're saying with this question we're saying 20 meters is represented by 1 centimeter on the map. So 110 we need to convert into centimeters. So we're going to divide by 20. 110 meters divided by 20 is 5.5 centimeters. So get your compass out, get a length between the pin and the pencil of 5.5 centimeters and draw a nice big arc there. So we know this tree lies somewhere on this arc. Now the other thing we know about the tree, it's on a bearing of 220 degrees from C. Now a bearing is the angle measured from north moving clockwise. So we need this really big reflex angle here right round to 220. Now if you've got one of those protractors which is a circle, so does the full 360 degrees, you can just quite easily measure the 220. I think if you've just got one of the normal sort of moon-shaped protractors, you're better off just working out this angle here, so you're coming the other way, which of course is just going to be 140 degrees because the angles about a point add up to 360. So just get your protractor out, just do a little mark down here representing 220 degrees, and with a ruler draw in the straight line. So we know the tree is both on this pink line here but also on this blue arc here. So here X marks the spot where D is. Question 18. So we need to work out the circumference of the circle. Well, the formula is C equals pi times D. Cottage pies delicious, apple pies are too is one way to learn the formula. So C equals pi times D, the circumference equals pi times the diameter. Well, we're told that the diameter is 18, so on your calculator just do pi times 18, which gives you 56.548 ... Now 3 significant figures is 3 digits in total, so the 5 and the 6. Do we round the 5 up? No, we don't, because the next digit is not 5 or above. So our final answer is 56.5. Question 19. So we're going to use tracing paper for this question. So first of all, mark the centre of rotation, which is at -2, -1. Put your tracing paper over this centre and over the shape and draw around the shape. I would suggest also on the tracing paper you just draw a little arrow pointing upwards to help you with rotation. Then go and put your pencil mark here so it's acting as your swivel points, and we're moving 6 and rotating 90 degrees clockwise, so shift the tracing paper around until the arrow is pointing to your right, then pressing through the tracing paper just to get an indent on the paper below. You'll get this shape. Just fill that in with pencil, but then just go back and double check. Just make sure when you rotate this shape you actually get back onto here and the tracing paper hasn't slipped as you sort of swiveled it round. Question 20. So we have basically got white, blue and red counters in a bag, and we're told that the probability of a red counter is 1/12. So the first thing we can ascertain is that the probability of white and blue together must be the rest, so that must be 11/12. So the probability of white and blue together must be 11/12 because the three as a whole have got to equal 1. Now the second thing we're told is that the probability it takes a white counter is 3 times the probability it takes a blue counter. So choose to let the probability of getting the smaller one, so the blue counter, choose to let that equal x, and what we then know is the probability of getting a white counter is 3 times this probability, so that must be 3x. So the probability of a white counter is 3x, the probability of a blue counter is x, and what we know is these two combined must equal 11/12. So we can construct an equation 3x plus x equals 11/12. Then this is quite straightforward to solve. We gather our x's together, so 4x equals 11/12. We divide by 4 and we get x equaling 11/48. Question 21. So we're told that there are 14.5 fewer mobiles were sold in 2015, first 3 months of 2015. Okay, so 14.5% fewer mobiles. So 100% take away 14.5% leaves us with 85.5%. So that's the number of mobiles that were actually sold in the first 3 months of 2015, 85.5% of the previous year. So turning this into a multiplier, we just divide this by 100, giving us a multiplier of 0.855. So taking our 62 million in those months, in the last 3 months of 2014, taking our 62 million, multiplying this by our multiplier, we get 53.01 million. Now for part B, we're being asked to work out the percentage decrease from 2013 to 2014. Now to work out a percentage increase or decrease between two numbers, you work out the change and you divide this by the original amount, and to turn it into a percentage you times this by 100. So the change, the decrease, is 1656 take away 1404, which is 252. So the change, the decrease, is 252. We divide this by the original amount, so that's the 2013 amount of 1656, and then we multiply this answer by 100, giving us 15.217 ... which is 15.2 to 1 decimal place. Now for part C, we've got to work out an estimate for the total number of minutes used on the mobile phone. Now we know on 3 occasions the phone was used for between 0 and 10 minutes. On 16 occasions for between 10 and 20 minutes, and so on. Now this is an estimate because we don't actually know how long was actually spent on the phone on each of these 3 occasions, for example. We just know it was between 0 and 10 minutes. It might have been just a few seconds, it might have been 9.5 minutes, who knows. So the best we can do is make an estimate, and we assume it's the midpoint. So the first thing we do is put in a column of midpoints, halfway between 0 and 10, 10 and 20, and so on. So these are our midpoints. From then onwards, we just assume this is exactly how long each call took. So we're going to say that 3 calls took exactly 5 minutes. Well, that's obviously 15 minutes when we cross multiply. We're going to say 16 calls took exactly 15 minutes, and so on. So you cross multiply these numbers, giving us these subtotals of minutes. We then add up these subtotals to give us a final total estimate of 590 minutes. Question 22. So for part A, we've got to list the members of A union B. So A union B is all the numbers that are in A or B or both. Now clearly these are the numbers that are in B. What numbers are in A? Well, the numbers that are in A are the even numbers, but these are the even numbers in our universal set. That this whole question, we're only considering these numbers 1 to 12. So the actual even numbers in A are the even numbers within our universal set. So that's 2, 4, 6, 8, 10 and 12. So for this question, A is these numbers and B is these numbers. So A union B is all of these numbers and all of these numbers. So that's your final answer for part A. Now for part B, we were asked this: is it true that 20 is a member of A? Well, we can see 20 is not a member of A. So we've got to give a reason why it's not. So no, and the reason I'm giving is because 20 is not a member of the universal set. So it is an even number, but it's not an even number in our universal set. It's not one of the even numbers that we're considering. Now for part C, this is quite tricky. So let's start off with all the possible numbers to start with that we're at least considering may be in C. So I've listed out the universal set as a starting point. Now let's just work our way through these facts. We're told that A intersection C equals an empty set. So there are no numbers that are in both A and C. So we're trying to find the numbers in C, and we're being told that none of them are in A. So straight away we can eliminate all the numbers that are in A. So that's why these pink lines I've gone and crossed off the possibility of 2, 4, 6, 8, 10 and 12. So they're gone. Okay. Now the second fact I've been given is that the only numbers that are in B and C is 7. So the only numbers that are in B and our new set C is 7. So straight away I'm going to write down 7 as being one of my answers, because we're being told that's in C. But then what I can then do, I can then go and say, so the other members in B can't be in C. So I can now eliminate 4, 8 and 11. That's why I've gone and put these green lines through 4, 8 and 11. They can't be in C because the only numbers that are in B and C is the number 7. So what numbers does that leave me with? Because we're being told the set C has 3 members. Well, it's definitely got 7 in it. And then we just need to choose 2 of the remaining numbers. So in here you can put any 2 of our 4 remaining numbers of 1, 3, 5 and 9. Question 23. Well, I think this is quite a nice easy question to finish. So just following the index laws here, when you're multiplying you add the powers. So 5 add 8 is 13. So the numerator becomes y to the power of 13, and this is having to be divided by y to the power of 4. Now when you're dividing, you subtract the powers. 13 take away 4 is 9. So y to the power of 9. Now for part B, we've got to first of all expand the brackets using the double claw. So it is x times x, which is x squared, x times minus 3, which is minus 3x, 7 times x, which is plus 7x, and 7 times minus 3, which is minus 21. So that's us having expanded the pair of brackets. We've now got to simplify them by gathering like terms. So the only like terms are these x's in the middle. Minus 3x plus 7x is plus 4x. So our final answer is x squared plus 4x minus 21.